Welcome to part 10. My hair is messed up, but I guess that's how we have to roll today. Yeah, part 10. Hi there, Rash. Welcome. So I have two boxes in front of me, which is more or less what we have left. I printed a lot of parts. Like these are all printed on the machine itself. That's why we added the panels last week, so they can print ABS. And it worked pretty well. We had a bit of like trouble here and there in the beginning. Um, so just to like look at a couple of parts for a second. So at first, let me actually go really close. We had a bit of issue with the surface here, like it was over extruded. I actually never found out why. Like I reduced the top surface flow to 0.7, which then solved the problem. And at some point it was like super under extruded on the surface. Um, this one? No, it was not this one. One of these white ones. Yeah, it was like super under extruded at some point. Not sure if you can really see that on camera, but hi there, Ravenkeeper. Welcome to the stream. But yes, at some point it was like super under extruded, and I was like, okay, let's put it back to 1, and that was fine, which I think that was dispatch. So don't ask me why the top surface flow varied so much, but now it's stable, so I did not really look into that. So yeah, like these parts are quite good, except for the top surface flow being quite horrendous. Like on the sides, they look quite good. One other issue, we configured the temperature probe for the new hot end incorrectly in the last stream. So at room temperature was pretty much okay, but at the higher temperatures like 220, 30, 40, 50, the measured temperature was a lot lower than the actual temperature, which actually caused the filament to almost burn. Because I set it at 260 is my normal printing temperature for this ABS. And it turned out like way too hot. So it was kind of like really bad. The surface was like not nice and like, yeah, generally not great. I was just improving as I go, as I went basically, and this was one of the last parts. So you see the top surface flow is kind of like pretty much spot on now. I still have a bit of issues with overhangs. Let me actually get this a bit closer. So it's a bit hard to see with black, but you see there's a little bit of drooping here. Like it's not bad, it's just not perfect. We will swap out the part cooling fan just to make sure that it's reliable. I had heard some stories that the fans from this kit are not super reliable long term, so I'll just swap them out anyways. And then we swap in like a fan that has a bit more cooling, but especially like with ABS at high chamber temperatures, you need like quite a lot of cooling to actually cool. Hi there, Kumbum. Welcome. So yeah, I mean, these parts look pretty good. I'm really happy with the top surface now. Like, it's really smooth. I also calibrated the small area compensation. So also here in these like smaller areas, like it's very nice. Layer stacking is very nice. These weird artifacts you see there, that's the camera. I don't see them on the part. But yeah, overall, like they turned out really nice. So this was like the last iteration of parts. Like they're not all this good. I mean, I already showed this one where the top surface flow is like this. But it's, yeah, I don't care, to be honest. Oh yeah, we also had one issue where the filament was stuck at some point. That turned out to be the retraction settings. I didn't change the retraction settings from the stock 2.4 profile in Orca. And the stock was 0.8 millimeter retraction. This was too much for the hot end, and this hot end seemingly known for like the filament getting stuck basically if you retract too much. So I changed now to 0.2, and that works great. Like I have no oozing or something, so that is perfect. Yeah, it's a whole bin of parts. They're all pretty good. They're not perfect. I'm not claiming that in any way, shape, or form, but like for a printer that's pretty much out of the factory, it's pretty good. So yeah, like really lots of parts. So we have a lot of work in front of us today. Let me get this, not the 41. Let me get this out of the way right away. Then there's one big issue I have. So generally the printer works great. I'm very happy with it. There is, I mean, there were like two issues. There was like this like rejection issue which I fixed. There's one issue I did not yet fix, and that is quite the bummer. And I printed now, I would say like 60 hours or something like that with the machine. So I have a fair bit of printing on it. And after, I don't know, like 50-ish hours, I start having like random CAN bus communication issues. So basically the printer would just go into the error state and would say like communication with MCU EBB failed. And then in the logs, I went through Clippy logs basically like within like a couple of seconds, like there was a lot of like resends on the canvas, and then Clipper said like, oh, communication lost. So that is not cool. I already tried, like I checked the cable on the electronic side basically. So I'm pretty sure that the cable on the toolhead side is not perfectly mounted. Like it's okay with how it is, but it still has the issue. So something is not not there. Oh, Ramkeeper back soon, dinner time. Yeah, well, important stuff needs to be happening here. So yeah, I'm pretty sure the canvas cable on toolhead side is not okay. And we got blessed. I actually didn't see where I put it, but the kit came with two of these PG7 strain reliefs. So what we will do is we will, that's kind of like the bad part, we have to run, like remove the entire canvas cable. And then somewhere in here, I've seen it here, we have these this little part, which is a replacement for the cable mount, basically for toolhead. And I think you can already see it, how it works. Like this is basically taking in this PG7. And then the cable comes out here, makes it a loop, and then goes in. So at the moment, basically the plug takes most of the strain if the toolhead is moving. And I think what happens is that sometimes this just wiggles a bit and causes communication issues. So this PG7 basically prevents that by just having this extra loop. So all the strain is here on the part, on the plastic, but not on the plug. So this is what we will install. I don't know why the kit comes with two, because I also know the printed parts come with a normal bracket here, not with the PG7 one. So I'm not quite sure why they give you two, but we have two, so let's just make use of that. That's like one lesson learned. If I would rebuild the printer, I would directly go with this part because it's a lot better than the standard one. Cool. Yes. Let's start. So the first part will be a bit annoying. And I'm actually also last time I was running out a bit of space here, so maybe we can just put the printed parts and this part bit down here on the chair. And let's just start. One thing that's really nice, like I really like that, the magnetic panels, super easy to remove. Like also printed a bunch of PLA now. And it's just very nice. That you can just remove the panels like on the fly. So if you print PLA, you don't want the temperature to be too hot. So you don't want a chamber. But then literally you do what I do now and you just quickly pull off the panels. And now you have a open machine, which is pretty nice. Like for maintenance, but also for printing. The only thing that is a bit painful is like these brackets here, like the corner brackets, they're in a specific position. And I noticed because I glued the corners, a panel only fits really well in one position, basically in one orientation on the frame. Maybe we can improve that for the future, but yeah. And also the middle spots, like these middle pieces here, I don't have yet. And so far, like the panels are not chattering or something, so I don't think I need them for now. I will add them if I see problems, but seems to work. How much does entire project cost? The kit itself basically includes all you need. And the kit is, you need to check in your currency. It's like around $850 or something. Depends from which warehouse you order and stuff like that. I have a link in the description if you want to buy one. Please use my affiliate link. So the kit comes with everything you need. The only thing you need extra is grease for the rails. So I have this like so up there, but I have this big bucket of like of grease that I bought like a couple of years ago. Not expensive. So let's say like the printer is, let's just say $850. And then you need like the grease is maybe 10. Then you need, that's it. That's basically, I think, the only thing you need extra. What I will recommend, because I heard from more than one person that the fans in this kit are not super reliable, I would just spend like another $40-50 to just swap out the fans right away with GDS time fans, or yeah, I think GDS time fans are like a good solution. They're relatively cheap. They're known to work well. And you don't get fakes. Like with Sunon fans, you get a lot of fakes. The GDSM, I think, are relatively reliable. So that's, I think, the only thing. Oh yeah, and the hot end. So they have different versions of this kit. The base kit, which this is, comes without a hot end. Sorry, it comes with a no, that's wrong. It comes with a V6 hot end, which I have here. So it's like a very basic old school V6 hot end. But this will limit the entire printer because it's just like it's a very basic hot end. It's not really good for ABS printing because it can't really sustain high temperatures. So this definitely needs to be replaced. They happily sell you like the kit with a different hot end and you have to pay extra. I ended up with a very cheap-ish hot end. And so far, like it got recommended by a couple of people. It works really well. This is a $20 hot end. This is the TZ. I have 3 of these. Like one is in here. I have two extra. This is a TZ E3 2.0. I will also put a link in the description, I think, at some point. But yeah, this is like very cheap. Has very high flow rate. Very good overall hot end for the price. So I would say the total cost also depends on the printer size. This is a 300, so I think the 300 is $850. I would say the total cost would be maybe like 900, 920 if you get the grease, the replacement fans, the replacement hot end, and I think that's it. So it pretty much comes with everything you need. I got the kit delivered yesterday. Happy to hear, Rush. Did you already start building, or is it still packed? Oh yeah, I added a little bit of paper here to keep the heat in because we didn't have this assembled yet for the ABS printing. They work quite well. And overall, I think from the kit, I can say like all the components seem to be good quality. The only thing that was a bit subpar was the foam tape, but yeah, it's foam tape. It's not super essential. And the fans, I didn't have problems myself, but I heard from other people that they had the fans fail. Already like filament stuff all over the place. Okay. Then let's take that apart. I wonder, maybe this is a good perspective for you. What is the strong point of this printer? Like, how is it different from fully assembled printers from other brands? Well, the strong point is that you have a lot of fun. That's the strong point. Like, I would say the ready-made printers are pretty good by now. There was a time where, like, this is like relatively old design, I would say. Like, it's available for a couple of years. Like, they iterated on it. Like this 2.4 R2. So there was a 2.3, 2.2, 2.1. So there are a couple of generations in. I would say generally the ready-made printers are pretty good by now. Like this is a very good printer if you put it together very good. That's always the caveat, right? Because you do it yourself. Like the overall quality you get out of it depends a bit on how well you put it together. If you do this correctly, this can be like an excellent printer without any questions asked. The benefit is this size, I would say. This is one of the benefits, given that you get the big ones, right? Like there's also 250 variant of this machine. Why is the screw so tight? So there's also a 250 variant, and with the 250, it's obviously not the size. This is 300, so it's the medium one, and then there's the 350. The 300, I think there are not a lot of like commercial options, especially the 350. There's not a lot of commercial options at that size. That are not like industrial grade, right? Like not a printer, you don't want to spend like 5,000 euro for a printer. Looking at a Prusa XL or something, I think that is 350. So it's a relatively big printer, which you can get in this context for a relatively low price then, and it's a very capable machine from the hardware. Hi there, Steve. Welcome. Of the same price, I mean, on the same price, you would look at something like the Creality K series, I think, would be similarly priced, a bit cheaper than. You would look at Bamboo P1P, like these machines. And I think compared to these machines, I mean, it's still like a capable printer, but then you're already like in the high-end segment where like it really depends what you want. The big thing on this machine is you can change whatever you want. So for me, like what I like to build printers is like, for me, it's just a lot of fun. Like I just like tinkering with the machines. I like improving them. I like modding them. Something I can be like proud of, you know, this is like my machine. I built that and there's no other like it at some point. And it's just like you can mod everything you want. Like it depends what you want, right? If you see 3D printing as a tool, like it's for you, it's not about the machine. It's more about I don't know, like if you are into like cosplaying or something and you need the printer to print stuff, just like super random example, or if you like doing engineering projects and you need a printer to create parts, right? Then I think you're better off with maybe a stock solution, because this is more like a project in itself. So if you buy a printer, then you can more or less expect it to just work. Whereas if you build a printer, there's some legwork involved, right? And there's not really like a customer support you can call if this breaks down. This is your machine for the most part, so you're responsible for fixing it, making sure it runs well. So this is more like a project. If you want a tool, a ready-made printer like a Creality K series or something might be like a better fit, because you unbox, like get out of the box and you get going, and for the most part you don't really have to understand a lot of what you're doing. Maybe I think at this point like slicers and everything are pretty good, to the point where like you don't really have to be like a printing expert to use these machines. But if you build your own printer, there's not necessarily like a profile, like a Orca profile stock built in that matches your machine. So you might need to create one yourself. You know, it's like it's a lot more work, but it's like fun, because it's really like yeah, it's your machine. You build it, you improve it, you configure it, you decide how it looks. Like I mean, this white and black color scheme, that is my choice. You can change parts in this machine. You can swap in mods and everything. Like you can fully make this your machine, and this is what I like. So to sum it up, it's maybe not about, is this like necessarily like a lot better than like Creality or Bamboo Lab? I don't know. Like it's a very good machine. If it's better depends a bit on the parts you choose, right? Like this can be like completely, like a Voron 2.4 can be made from very cheap parts. It can be made from extremely high quality parts, and that will of course influence how good the machine is itself. So it's more about like, what do you want? What do you want? Do you want the project or the tool? Also, you can customize to your liking, have fun building the printer, and also have better understanding when troubleshooting issues. Yeah, I think for me, it's also like learning. It's like a very, very good point, actually. Rush, that's a very good point. Like, you learn so much about electronics, mechanics while building these machines. And it's for me like one of the big benefits as well. Okay, so I'm not going to shift the camera too much. All I do is we unplug the CAN cable here that we have. And we need to get this out of here. So basically you see the black cable coming in here. No, you don't see it. But that's the CAN cable that we have to remove. So how did I get this off last time? Yeah, I think I have to do it to the other side. I have to do it like this. Yeah, and then it comes off. Yeah, okay, here we go. So this is relatively long, and I think this makes the whole run around. I have to be a bit careful with this one because the Wi-Fi antenna is attached to that. So let me just immediately put that back. Oh, this one was the one I said I can just slide out to the back. I don't know. Now I remember. Okay, so this is the CAN cable that goes to the tool head. Yeah, let me actually quickly close the center one at least up, just to keep everything in place. And these, of course, we have to loosen, which I need a screwdriver for. Guess I'll try later after getting a printer. Use this BOM and source parts myself and build it. If you source parts yourself, it's actually way more challenging than get a kit. But I read between the lines that you don't have a printer yet. So you don't need to, but it's extremely valuable to have a printer while building this. Because you have to print the parts. Technically, you can buy the parts, or there's also the names the PIF program, the Voron PIF, printed forward, so you can ask people to print the parts for you, and then when you have the printer ready, you can print parts for somebody else. But still, it's like very valuable if you can make parts on the fly. Like I have a couple of parts down here that were not part of the original parts, and I just like figured out I need them on the fly, and I was able to print them. But I think it's also good if it's like this shouldn't be your first printer. Like you should have a basic understanding of printers before building this. Okay, this is quite painful because we really have to get the entire cable out, which I'm not a huge fan of. Sure, the JST is not catching, but yeah, I think like, I mean, for me, my first printer was the Ender 3, and I modded like the hell out of this Ender 3, and that was like a very good learning experience for me in a certain sense, because I mean, I think a lot of people had Ender 3, so many people will know. But it was quite yeah, basically at the end, like nothing of the Ender 3 was the Ender 3 except the frame. I still have it down there. Now it's a Voron switchwire. And that's a very good learning thing, because then you learn step by step how the printer works, which parts do what, and then you can step by step get into it. Okay, so there's this JST plug here, and if this annoys me too much, because it's quite a pain to get through these PG7 connectors, I can just recrimp that. So I'm not going to be too careful with that. And actually, let me just... Let me just do this. And for these, I'm not sure if they fit. If okay, I can pull them one by one and then they fit. Cool. Okay, so we have quite a long cable. The problem is basically this plug here at the end. So this part we will replace. This is the one we used so far, and this is the one we're gonna use. So they're almost identical. You see, they both have this like little cutout here for the USB-C here and here. It's black, so it's like a bit hard to see, but there you go. And they have the same mounting here. We actually have to add one heatsink insert here. The only difference is now basically we will route the cable through here. And to do that, like this plug's basically the opposite side, of course, we have to remove this one first. And this is more or less why I had to remove the entire cable. Okay, then you see like I braided the cable like for the section that's open, and there you also see here there's this metal piano wire in there to make sure the cable kind of has like some rigidity to it. The problem is the piano wire ends here in the slightly thicker part, and I think we have to move that. Like, I mean, first we have to get it out of this here, which will be quite challenging. Because the cable now with the new part, it has to be a little bit different, like we loop it around first. So yeah, let me try to... It was quite a pain to get in, so I expect nothing more than pain to get it out. And I made such a nice like sleeving here. Very sad to see it go. Oh wow, I missed half the chat again. Hi there, Alex, welcome. You can get a kit with only functional parts, so just get a functional printer. Yeah, exactly. That's more or less what I have now here, right? Like we don't have the skirts on the bottom. We don't have any of the bling parts. It's just like it's just a functional printer. Okay, let me also get this heat shrink off, because this is not going to be reused. You have to redo that. That's what I've got. Functional printed parts from Formbot. Yeah. And I think the parts were quite good, Mr. Desai. And welcome to the stream, by the way. So just by the functioning parts and print the rest. Yeah, basically the idea of functioning parts is that you get everything you need to get a like, functioning printer. But then like more or less this bunch of parts I have here, right? You have skirts, fan covers, like all the parts to make it look nice. You don't really need them for a functional machine. And then once the machine is printing, it can print its own parts, basically. That's the idea. Quite good quality, actually. Yeah, that's nice. Putting all the conversation parts. Yeah, sounds good. Yeah, no, I think it's a very good approach. But still, I would not recommend that if you did not have a printer before. Because there are, like, it's not as easy as putting a Lego set together. Like, there's some challenges you can encounter. Just take my experience now with this kit. I would say I'm a quite experienced printer person. And there was like this clipper issue in the beginning that really threw me like a loop. And actually, like, Mr. Design like found the correct article in the end to help me solve it. But that was quite a experience. Yeah, so there's a second bit of electrical tape here that holds the piano wire. I think it's quite a good construction in theory. The only problem is now we have to shift everything a bit. And the sleeving here at the end is not having a good time. And let me just push the sleeving like, oh, I just shot the PG7 connector over there. I have to get to it in a second. Okay. So firstly, so there's the part we have to go through, right? So in the end, this needs to look something like this, that the plug is here, like this, on the side. This needs to loop through here. So we have something like this. Something like this. And then this cable needs to go through the hole. So we basically have to start by taking this cable and putting it through here. What makes expensive printers expensive? I think a lot of things. It just adds up, I would say. Expensive printers, for example, use linear rails. Linear rails are relatively expensive. Like the linear rails in this machine, I would say are like 100 euros on their own, just the linear rails. Stepper motors, I don't think make a huge amount of the money. Yeah, also stepper motors are like easy, like 100 for a kit of stepper motors that you need for this machine. It really just adds up. It really adds up. A hot end, you can get a hot end for like 5 euros. But then basically you're very limited from flow rate. The extrusion might be not super reliable. So then basically like the higher end options would be more like starting at $50 or euros. So it just adds up. That's really what I can say. If you get like an Ender for like 150 euros or something, you get the cheapest of everything basically. And in general, with everything in life, you usually get what you pay for. So cheap printers are generally lacking in, I wouldn't say not necessarily in reliability anymore as much, but definitely in print quality. You see a difference there. It's just like higher quality parts have like, for example, more consistent extrusion, more consistent motion. So these things make a difference. Okay, I just used electrical tape to add the piano wire again to both ends. Then let me think. So I think it makes sense now to push the sleeve back over that. Oh, the sleeve basically is also not part of the kit, but they have a different one, but I didn't like that as much, so I added my added my own. It's also very cheap. Okay. The sleeving kind of like is damaged here at the end, so I'm gonna just cut it off a bit. There are printers at 200 and 2000. What makes the cost much different? Yeah, it's just like a lot of like small things. As I mentioned, like for example, the cheaper printers, they usually use V rollers for motion, which is very cheap, but it's not as precise. So this will show up then, for example, in like small things of the print quality. But again, if you never had a printer, like I would firstly make sure you know what you want. Like, do you want to print or do you want to tinker? And for a first printer, just melting the ends here a bit. For a first printer, I think you should buy something stock that you can modify. Maybe ask in some communities what would be like a good moddable start print, like first printer. Okay, then this is the end of the PG7. Let me make sure I have the right orientation. So this needs to go with the thread first. I got my kit from Ali as they had an offer on the kit. When you get off-the-shelf printer, they are just using manufacturer software, and when you get a Voron, it's open source. Yeah, I think there's also like a lot of like stock printers that are open, like using like standard software. For example, the Creality machines, like all the ones with Clipper are kind of like open source, so you can actually mod them quite well. So here I now have the sleeving open. It's a bit hard to push over. I will just use a tiny bit of electrical tape to hold it down for a second. So basically, to be clear, like this is not like a beginner machine. That's I think what I can say. Like if you really start with something that doesn't give you too much trouble. If you want to get into the hobby 3D printing, I would maybe stay away from something like a Bamboo Lab, because then you don't learn anything. But I think like your first printer, let's say like this, your first printer should most likely not be more than 350, 400 euros. That's what I would suggest. Oh no. Ah, shit. There's this rubber seal here that prevents the thing from twisting, and this is the one where it flew off. This one still has it on, and this one is separate. What's the cheapest DIY enclosed printer? I think the 1.0 would be it. I see kits for like 380 in the USA. Well, if it's you said DIY might be it. There might be some variants of the Rook that have an enclosure. But also, yeah, like if you really like Kumbum, if you really want to build a printer, like again, like I would not recommend building a printer as your first. I think a V0 would be like a very good choice. It's very small, which is enough to build print all parts for this machine. But it's way easier to build. Okay, second attempt. And this should already hold it in place a bit. Just need to see that we have the length somewhat sorted. That's a bit too short. But I kind of want to terminate the sleeving like in the connector here. So I'm just adjusting it a bit. Honestly, if the quality of the parts that I'm paying for, if it, I like the other because all rebuild to make it better. Yeah, exactly. I mean, it's really the quality of the parts. It's you can get, I mentioned before, like right, like you can get hot ends like incredibly cheap. But yeah, you get what you pay for. And this goes for every single screw. Like you can pay a lot more for screws and you get better screws. And they will have better quality. They will be easier to use. They will be more reliable. Like they will not break. I feel like I'm pulling more cable, but it doesn't get longer. Oh, we should also pay attention where we put the piano wire. That should be somewhere towards the end here. I feel like now it's relatively long, but I think it's still like a good amount. Maybe we can pull in a tad. And the piano wire starts here, so that's also quite good. Okay, then let me might be really like too long now. But we can do it. Let's roll with that. Okay. Then let's shoot the PG7 connector, this orientation. There's new Elego Carbon Centauri for $300. I don't know much about it, but it costs $69. Yeah, I mean like the Centauri Carbon. It is a relatively cheap machine. So it's quite loud. I'm not quite sure about the print quality, but yeah, as always, you get what you pay for. I would actually recommend not getting this one. I mean, again, like it depends what you want. If you just want to print, might be a fine machine. If you want to learn something and mod the machine, might not be the machine because it's not using a lot of open source stuff. Like it's quite closed up. It's a very specific special system. So you can't really like do a lot with it later on. See, so here is the the piano wire ends now before the plug. Ah, shit. That's not what I wanted. So I feel like we have to move the piano wire a bit down. Okay. I want the piano wire to terminate inside the PG7 connector. That's a bit annoying. Not quite sure if I could have measured that before. Where's the start here? Okay, like this should be good. I'll put that back. Maybe I have to use a new one. Yeah, use a new one. Let me actually use this one. For this end, we have this one. And now we have. Now it's a bit short again. Yeah, now it's good. Okay. So let's align the sleeving here with the end of the piano wire. So around here. It's really not helping that everything jumps around on the cable. Once it's screwed in here, like the cable is locked, so now it's safe. But before that, it's a bit tricky to judge. Yeah, but I think this is a very good cable length now. That gives us enough reach. Okay, then we know the piano wire is also like around the length we need to bridge, so this ends here. I need to quickly get the PG7 connector I shot over there. 1 second. So, almost there. Let me make sure this is the right way I put it on. It needs to go in this way. And I think we can also directly put the connector on the wire with it. You have to push the CAN cables through. The green one got lost. I mean, the easiest if you do something like this is always like use a bit of electrical tape to put the cables together. But I like pain, so I do it the hard way. Here I'll do the smart way. So let's just, actually let's really just use a bit of tape to tape this down here. Because this will be the end. Let's use heat shrink. But let me do it temporarily now with tape, and then let's use a bit of heat shrink to secure that. If it wants to go on. I think I used too much electrical tape now. Yeah, here we go. Step by step. No, that does not work. I have to quickly redo that. Yeah, come on. If you want to build like a Voron or some other printer in this category, make sure to just watch like at least, I would say, 2 different build guides, start to finish for the machine. Really know what you get yourself into. Okay, so the piano wire ends. Where does it end? Here is the piano wire end. So I try to have this somewhere here. Just temporarily screwing this down. So this would be our cable. Man, this was like quite a hard thing to do. Then let's get my soldering iron. Then we also get some sleeving. Let's finish up the end of that course of the sleeve there. Also, we have to put 1 heatset insert, right? I think. No, heat shrink is not here. Then heat shrink must be here. And actually, I'm not sure if this is thick enough. I don't think this fits. This one is with glue. I don't think this will. No, this will not fit. So the heat shrink with glue would be nice here because it just secures everything a little bit more together. Let's try this one. I've decided on Soul SVO6 Ace, and I think there are many assembly tutorials on it. Yeah, I think the Soul machines are pretty cool. That's a great start. And I think also the SVO6 you can mod quite a bit. I think it has Clipper. Double check that it has Clipper. If it has Clipper, you can really mod a lot of stuff with it because it's like a standard printer software. Like this also runs Clipper. And then you can just really mod it to whatever you want and then learn. And if you really see like you enjoy modding the machine and like working with it, then you can build something like this. I think it's a good way to go about it. Yeah, let me actually let's first melt them together a bit, the ends here. And this should go on a bit easier. I should have used maybe one size up. Yeah, almost gonna have to shrink it. So I move it all the way down basically. The first things peek out on the bottom, and I move it just a bit back so that it has the most chance of holding the heat shrink in there. I forgot the word how this is called. Okay. This is a very nice cable. Let's put it into our machine after we put the one heatsink insert that I almost forgot now. All right, screen protector, welcome. Who do you think about OpenOS, a device for smart device that would not be focused on Google products? So it's like an Android replacement, and will be compatible with older devices. I have no clue. I have no clue about that. I know that if you have like custom Android ROMs, they need to be specific for this one device. So you need to check that your specific device is compatible. That's the only thing I know. I didn't do custom ROMs for Android for like the longest time. Yes, a Clipper. Another question. I know what Clipper is. Is it like an operating system or slicer or what? And why is everyone talking about it? Clipper is like, think of it like the operating system of the printer. It's the software that controls your printer. So basically you have 3D printing files from Printables or some other online source, Thingiverse or whatever there is. And you then slice that with your slicer, which would be Prusa slicer, Orca slicer, whatever slicer. And then you put this sliced G-code file on your printer, and then Clipper takes over and makes sure to print it. That is, I think, the long and short of it. Okay, let me screw the PG7 in and then screw this back in. Here's where the piano wire ends, so this should be in the PG7 connector. Okay. I just kind of like flapped it over here for now. And let's put this back. Fluid or mainsail, which is better? Try out. You don't have to choose between one. You can install both of them in parallel and just try whatever you want. I like mainsail more. I don't like the interface of Fluid, but it's very personal to me. I know a lot of people prefer Fluid. I'm a mainsail guy, but like just try it out. Like you can install both of them. There's no big impact on your printer if you have two interfaces installed. They don't do anything unless you use them. So if you just use one, there's no additional impact on your machine. So you can really just install both of them. Put one on port 80, one on port 8080 or something, and then just see whichever you like more. I kind of want to look into like removable doors, because like the doors is the only thing I can't remove on the fly. And actually removing them is a bit annoying. I played around now with the doors so that they kind of close quite okay. So now I don't want to touch them anymore. Oh, I think the screw was too short. Is this a different one? Oh, it's the same. Wait a second. Because it didn't tighten at the end. I just quickly check that this is indeed long enough to go through. Yeah, definitely. It doesn't pull tight. Oh, it was just not it was just not in. Okay, my bad. Okay, so this arm is now secured. And now there will be like this cable. Oh shit, I forgot. This needs to go in the loop before we screw it in. Okay, let's try this again. An annoying part is, I'm not sure if this will fix my problem. So I will see it if I have another print failure. Yeah, it's a good length. I'm glad we tried a couple of times. Always good to take your time with stuff like that. Don't rush it. If you rush it, you do it twice. I'm an expert on doing that. So Clipper software lets you tinker it as much as you like. Basically, yes. I mean, there are three like open source like printer firmwares. There's Marlin, like let's start from there's RepRap, which is like super old school. It's like the first one. It's like very old at this point. It's still like maintained and it's like up to date. It's like a valid choice to run your printer. Like this is still good software. There's Marlin, which I think from the three is the most difficult to use because you have to compile your firmware for everything. I never used RepRap, so take my my knowledge that with a grain of salt. But Marlin is relatively complicated to use and to configure because you have to compile the firmware every time you want to change something. And Clipper is the most modern one. It has the downside. The other two can run on the printer mainboard itself. Clipper needs a Linux machine, like a Raspberry Pi or something to run on, which makes it a lot more complicated to set up and sometimes also to troubleshoot. But it's the most capable, I would say, and once it's running, the most easy to make changes to. And because it's open source, like it's basically designed to run on any machine, so you can configure any printer with Clipper, and it's very adaptable because of that. Okay, I mean this looks great to me. Let me just quickly see if we move it all the way to the opposite side. There's no tension on the cable. This is great. Like it bends a bit more shallow, of course, but this is good. Piano wire goes all the way into the PG7 on both sides, so this is good. And now, like when the printer moves here, and if we do some moves here, this plug sees no force applied to it because all the force goes into this arm here basically, and then the cable here sees like no force, so there's no movement on plug. And I think what happened, or like the most common cause for the issue I'm seeing is basically that there's like movement on the plug, and then like when the plug moves, there's like a short signal loss basically, either in power or in the communication, and then like your print fails, and you don't want that. The only thing, see now, it's like kind of need to rotate that a bit. That cable here has more tendency to go back because right now, like before, it had like tendency to go into the belt. You don't want anything to touch this belt, so just rotate that. That's like forcing it more or less in back to the panel. That doesn't touch the belt here. That basically, no matter where you are, like the cable should not go towards the belt. Okay. If I would have been smart before shutting the printer down, I would have moved it up. Now we have to kind of like inch it up step by step. Hi there, Angel. Clipper makes it easy to tinker as you don't have to rebuild the firmware for any changes. You just change your config. Yeah, I think that's the main benefit of Clipper. Because I think also, I mean, the other benefit is like the solid, like, or like Clipper's ability to use different, like multiple printer mainboards is I think also like one that the other firmwares can't do. Besides that, I think Marlin and RepRap, they have, I mean, it's a printer software, right? Like a firmware. It's like they all can print, and they all have like input shaper and everything. I think Clipper has the most robust input shaper implementation. I think that's a fair point, or like a fair thing to say. But they all have input shaper and everything. There was like one thing like a couple of years ago where only Clipper had input shaper. Let's see if we can. Let me make sure the cables are somewhat sorted in here. That's not complete chaos. Okay. And then let's just put this in here. Let me just quickly close a couple that the cables don't get any ideas of going places. Hej, det er Patsimir. Yeah, I think this is like one thing. This is how we should have done it, like from the start, like with this PG7 connector here. This is much more stable. But to be honest, I don't have any, like I have at the same arm I have here or used before, and that I think is like a valid choice to use. I have the same on the Switchfire. Never had issues like that before. But on Switchfire, it also only moves left and right, not like 3D basically. So I'm not quite sure if this is like, I mean, it's a big difference, but if this is the cause of what I'm seeing. But I know other people use the same, and generally the plugs are stable. Maybe mine is just has some production defect or not. I don't know. Let's see. But this should solve it. If that doesn't solve it, I would replace the cable. That would be the next step for me. Okay, let's see if we can maneuver the crimped cables through here to their final destination. Here we go. I think a smart thing to do, actually, let me still do it. Like, it's kind of like lost or like pointless by now. So you don't want the twist of the cable to you don't want to lose the twist on your CAN bus cable. The twist is basically what protects the signal in a certain way. In a certain way, it protects the signal. So you don't want to lose the twist. And if I push this through here, I kind of fear that I will lose my twist a bit. So I just tape them together. And then forcefully push it through here, although it doesn't really want to be there. Here we go. Yeah, especially because we run the canvas wire like alongside the stepper cables here. It's very important that you have this twist in there. Technically, I think a shielded cable would be even better, because you don't want to like have noise on your CAN bus signal, because that will cause issues. I posted on Discord a link. A guy had similar issues and was interference between the cable and the step cable. Yeah, I can vouch for that. Like normally, I mean, I'm not the only one running it this way. Let's put it like that, right? So this is like a standard setup. This should work, but then you never know what kind of like small production differences or whatever is in there. But yeah, you see the twist here in this cable, like they're twisted around each other, and that eliminates induced interference, I think. And the stepper motors, because they are like relatively high power and like constantly change the voltage on the cables, they induce like signal basically, or like interference. So running any data signal alongside stepper wires, a recipe for problems in general, like not specifically CAN bus. I had the same, like when I had my Ender 3 setup. The Ender 3 has basically this like sleeve on Z that moves up and down, that connects the cable from the base to the Z axis basically. And I had a camera mounted, which was a very popular mod, to have the camera in front of this like Ender logo. And like if you look at the printer from the front, it's like here. For you, it's like this side. And then I ran the data wire of the camera through the sleeve alongside the extruder stepper and the X stepper. And when the printer moved, you saw that the signal of the image, like the image of the camera, got like grainy. And it was exactly that, like the stepper, the voltage from the stepper cables, like the change of voltage induced like interference in the cable of the camera, and you saw that in the image, with the image getting like bad. That's really, it's a thing, and you can observe it. And basically, what a bad image is for a camera, I mean, you can survive a bad image. What you cannot survive is a loss of CAN bus communication. I mean, you can, but your print can't. Although I mentioned it in Discord, I'm very good by now at resuming failed prints. It's actually quite easy. The trick is only you have to figure out at which layer you are. On the Switchwire, I had like at some point I had issues where the entire printer would just freeze, like Linux would freeze, which obviously killed anything going on. And wait, we said we can just do this. And what I did at some point is I added a layer change macro in Orca to print the Z height on every layer change. So basically the last Z height printed was the Z, like the layer that you were currently printing at. And okay, let me right away put the cover here because it's a bit of like a cramped cable channel. There we go. And then basically you just download the G-code file, you remove the start G-code, and then you remove, like you basically remove all the lines up to where the layer changes. And then you have a printed, like a file that you can print that basically skips the part that's already printed. And then the trick is like, don't move your printer. When it fails, don't move the printer manually. Immediately set the bed back to temperature. Then you set the nozzle back to temperature, and when the nozzle reaches temperature, you first use the set kinematic position command to set like an arbitrary X and Y position and the Z from the slicer. Then you move the printer up, you home X and Y, and then you have a correct Z, a correct X, correct Y, and then you can resume with your like partial file. It's quite a process, and there's no guarantee it works. It usually works, but no guarantee it works. And sometimes you see like a little bit of like a line where it stopped. Also, you will reprint part of the layer that failed. Unless you really figure out at which specific point it failed, and then you can also remove this part of the layer. CNC Kitchen has a really cool video about that. That's where I learned that. Kind of refined it over time, but that's the principle. He recommends shielded cable for CAN. Yeah, the problem is like I don't think there are shielded cables for CAN. I mean, technically you could use the Ethernet cable. These are shielded, and you could you have eight wires. You could combine technically 3 ground and 3 24-volt, and then you have still like CAN high and CAN low. But the twist is different on Ethernet and CAN. I'm not quite sure how much of a difference this makes. But I think quite a lot of people use Ethernet cables for CAN. Another candidate is HDMI cables. They're also shielded, but then you have like a lot more, like I think they have like 20 strands, and like none of them can really carry power, so that would be like not not the easiest to use. It works even with relative positioning. Well, it doesn't really matter what the positioning is. You mean relative positioning in the print file, or what relative positioning are you referring to? I'm like, no, I'm crimping the wrong one again. In the G code, yeah, it doesn't matter what the G code is. It does matter. I don't use relative positioning in my G code that doesn't use relative positioning. I think if you use relative positioning, you need to move the printhead exactly at the X, Y, Z coordinate where it stopped. The technique would also work, it's just harder. With absolute positioning, you only need to make sure to restore your Z, that the Z is at the correct height. So basically, wait, give me 1 second. Okay, that's kind of one. So basically, the printer, like in your Clipper firmware, it needs to say like Z4, and it must be like correct Z4, basically. If you have that, X and Y, you can always home. And then you will be pretty much exactly where you were before. Z, usually you cannot home Z, and that's the main problem. You can't home Z because there's a print on your print bed. Most printers home to Z-min, so towards the bed, and then obviously that route is blocked. I remember this cable was quite iffy to crimp, now that I crimp it. Yeah, so basically you just have to restore your Z. That the printer knows the correct position, that it can resume the print. And obviously don't move the don't move the bed. For the, I don't know, like I crimped that before today. I was like, not that much of drama. What do I want to say? Oh yeah, for the 2.4, the only problem is the gantry tends to like basically when the motor power goes off, the gantry moves a bit. Mine doesn't, luckily. But if yours does, then this is kind of like a showstopper. Okay, this is not a nice crimp. Yeah, that's what I thought. But yeah, CNC Kitchen has a really cool video about this, how to do that. And depending how, I'm sure why I'm not capable of crimping this wire right now. Depending how quick we are here today with all the things, maybe we can, in the test print at the end, we can just make it fail and resume it. And I can show you what to do. Thank you. That took like 5 attempts to crimp this. Then let's look, take a look at the original plug that we get the orientation. I think it's a bit too much twisted here. So the green goes on this side and the yellow goes on this side. Let me quickly get tweezers to push it in. Yeah, it's in. And only after an hour and a half, we fixed our CAN cable. That was not meant to be like the center, the most important topic of the stream. Okay, here we go. That's the center one. We still need this. This is the top one. Okay, here I'll just do the lazy route. So we just store the cable in here. Also, in case if we need to change the cable a bit, we still have length available. So you go here. Just, no, you go here. And no. You go here. And then let's put this in place. And close that up. And then this should be done. Okay. Step one. Well, I think this was the most important part because this actively interfered with my prints. I don't like that. I like my prints to succeed usually. Okay, but then actually let me just flip this bad boy over. As always, ignore the chaos around me. Let me just move this here a bit. And you kind of have that more center. Okay, then. I would say let's attack the skirts. So we are kind of like out of order here now in the manual because we did the panels already and everything. What we didn't do yet is the skirts. Which is here. See? I'm low-key afraid I forgot to print something. We will find out soon. Okay, so skirts. That's more or less the last big part. After the skirts, the only thing left is the exhaust fan. And the kit comes with this light bar, which I also want to install. I'm not going to keep that forever, but just like to complete the build of this kit, let's install the light bar. Let me actually quickly get this ready. Okay, so I would just follow the manual here for the skirts. There's not much to it. I'm saying there's not much to it. There's one thing to it, which is the screen. And I would actually skip over the screen for now and just do it at the end. So let me just quickly like get like the parts out of here, just so that we get a quick overview what is what. So now we also find parts like this mount for the screen. These are all spare parts. These are the exhaust parts. Should be one more of these. I have a quadrillion panel clips in here. Some of the panel clips are for the bottom panels. We will meet them at some point. But yeah, so they start with the screen. That's not really like applicable for us. I actually don't 100% know how to mount this screen. I did not look into this at all. So I would just mount the mount for the screen, and then let's do the screen a bit later. So they do the screen, we just skip over that. But then, yeah, heatset inserts. I could have known that we have to do some heatset inserts. So let's do that first. All the setup for nothing. Yeah, so these are for the screen. And this I don't like the print quality on, so I will definitely print again. I printed these two on the switch wire, so they're PLA. Hi everyone, welcome. And another thing I definitely need are screws. And in particular, we will need some heatset inserts. Okay, so let me just organize the parts. So these are the two parts that we look at in the manual, right? These are the two parts. Then we have these two parts, and we have this part. And all of them want some heatset inserts. So this is here on top. So this is done. Then these get one on top as well. Oh, a bit more chaotic than I wanted. Oh, we have one less. That's from the front. I think we need a bit more temperature. Okay. Then you get one on top. And two on front. Oh, ow. Maybe not put your thumb on the freshly inserted. Is the soldering tool or is it a dedicated tool for heat insert? This is a dedicated heat insert tool. You can technically do it with a normal soldering tip, but it's not as easy. So if you want to build a printer like this, there are some tools you're gonna need. This is definitely one of them. Others are, what else do you need? I think normally just like normal normal tools. I'm not sure, there's some for sure some. I mean, most likely you will need some basic crimping pliers in a kit. Did we have to crimp anything? I think technically you would get away without crimping anything except for the power supply cables. There we used crimping tools, but these are like hardware store crimping tools. So I said I don't think you need any specialized tools. Okay, not my best heated inserts, but they will do. Then, yes, there's more. So we have, I printed too many of these, I already know. So they insert 4 from the front here. I'll be a bit careful. I just do that on on the other part because I don't want to burn any holes in my table. For the PCU, yeah, exactly, Mr. Desai. For the PCU, we use the I'm not quite sure how they call it. I think the cable shoe. In German, they're called Kabelschuh. I'm not quite sure if it's the same in English. Oh, I was like, why is it so hard? I mean, if I turn off the soldering iron, that makes it relatively hard. Okay. Oh, we heat it insert the fans. Oh, this is the first for me. I'm not quite sure what temperature we need there. So these are the fans from the kit. Huh, that does fit. Interesting. Let's try one. No, that works. Makes a funny sound. Like it's bubbling or something. Oh, something with this cable annoys me today. I don't know. Like it doesn't do what I want. Smells like good things to inhale. This will like take off like at least a year of my lifespan. Worth it if you're having fun. That's true. Everything in life is dangerous and bad for your health. All the good things, at least. So can. No, I think with these things, like if you don't do this every day, it doesn't really matter. But if you do this like professionally every day, like look into some protective gear. Yeah, they do more screen stuff, more screen stuff. Here we go, non-screen stuff. Okay, so these are one of these parts is already here on the printer, so we have 4 corners. But these are the 3 corners we have available here, and they use M3x8, which I had a hunch that we need lots of M3x8s, so I left them already out. And yeah, I basically the people who like follow the streams for this print, we had problems with the screws not fitting on the parts I printed on the V0. And during the tuning of this machine, I noticed that for this ABS filament, I had the extrusion multiplier for the filament was like a tad high. And now you can see like this was actually, it was like 2%. And this 2% is all it needed to like all the screws are now falling through the holes. So sometimes it's the small things. And before I forget that, and it's literally just next to me, I'll quickly screw the same part And it already doesn't quite fit. Okay, well, comes the bigger operation. I have to move that like half a millimeter over. So, okay. Then yeah, they use so these are keystones. That's what I called. And the kit comes with one. Like this is used in servers a lot. This is like an Ethernet keystone. It basically is just an Ethernet plug on our port on each side. And we use this here that we have an Ethernet connector on the back. This one, I have no clue. It's somewhere in the printed parts, I think. Somewhere in there. I want to add a USB keystone here, which is in the mail. So I'll leave that blank for now. It's just a cover. Doesn't really matter. Part is we have like Ethernet here, which I don't use, but now we have it. Yes. Then let's get stuff started. So on the front, that should be the front. It's a bit hard to identify. Yeah, it's the front. You see the idlers peeking in here. So they have 4. Are these M3 already? It's an unlabeled bag, which is not very helpful. No, this is not M3. These look like M4. Here. And a lot of magnets, which we'll need in a second. That's what we also need in a second. Let me just park that. You know what's crazy? I ordered from China and Czech, and I had to pay import duty from the order from Czech, but not from the one China. And I'm in UK. Ah, shit. Well, but I think the one from the Czech warehouse was most likely the printer itself, right? From China was just the tool. Maybe there was some certain amount that is free, and like the printer was just over. I'm not quite sure how the import duty works in the UK, but yeah, that kind of sucks. That kind of sucks. Okay, then I think now, yeah, we have to get the printer back in place. Oh no, I packed the M3 8. Here we go. We still need plenty of these bad boys. We don't need any heat sensors anymore, which also means I can turn off the soldering iron. Both 3D printer kits and about the same value. Oh, okay, that sucks. I mean, the only other thing I can think of is that delivery from China had the duty prepaid. But yeah, it's there's this one printer shop in the UK, 123D, I think it's called. No, Printy, please. Yeah, there were like 1 or 2 shops in the UK I usually order from, but such a pain since Brexit that I don't. That's the short answer. It's like really painful, especially because of duty and stuff. Like for smaller orders, where did I not put the nuts? Did I put the nuts back as well? Oh, there's some random M38s. Careful. This flag is open. There are some like for small orders, they just charge you the Dutch VAT tax. And then I think you don't have any import duty. But for anything above, I think £100 or something in that ballpark, you also have to charge like pay import duty to you, and it just becomes like extremely like not worth it. Okay, let's start with the front. So I don't want to like turn the printer like a million times, so let's do all the all the parts on one side. This is quite a chunky boy by now. So usually it doesn't matter, but sometimes it does with the screw holes, like in which orientation you put these in, like facing this way or that way. So always try to align with what the manual has. Okay. Also need to check if we need 4 or more, because the manual shows like 250 build, but we are on a 300 build. But I think for this case, we are good. So these are 2 here. That's, oh wait, that's one with the keys on, that's for the back. This one goes here. So let's just move them both a bit in. And we can like catch from here and align the other one. Love the cable management. Thank you. Well, not all cables are there yet. We still are missing, well, the Ethernet cable. We are missing HDMI and USB. So it will might get a bit more chaotic in a second. I hope not too much, but a bit. But yeah, I'm a sucker for cable management. I can't stand if cables are flying all over the place. This is kind of like on the edge for me, because we just have this cable like flying, the separate cable for the separate like flying under the power supply. The hole is big enough. Come on. Okay. Why is it going in here? Thank you. This will be fun. Okay, so now it's like already attached, and you can just, oh shit. Then I thought you can just slide it over. I think it makes more sense to add these like white parts now, not like before, but the manual says otherwise, so let's follow the manual. Okay. And for these, let's be a little bit smarter. Let's align like this. It's well hidden, thank you. The thing I didn't do yet is like the they are a bit annoying to get in here, the screws. The stepper cables are still like the stock length, and Formbot gives you 4 times the same stepper cable for the Z steppers. So they're all the same length. So some are like, I mean, this one, for example, like it's way shorter than this one. And all of them are long enough for the 350 build. So they're just like quite long in general. Okay, let's quickly try this. So this should just fit. Yeah, should just fit here. Let's just mount this. So it's just like two more of the M3 peanuts. And then the screen, let's just see. Like that was kind of like on the bottom of my to-do list, to be honest. And the CAN cable already took quite a second for me to install. So let's see how far we get. Yeah. So yeah, I potentially shorten the stepper cables, just like to make it like good for the run. But before I do that, actually talking of steppers, I should plug this one here back in. I just want to be sure that everything is in a place I want it to be. Yeah, that fits quite nicely, like there's no gaps. Oh, we forgot. No, I was like, do we need heatsink inserts in here? But no, this is just like to access these holes. It's not like these parts where you have to go from the front. It's like, it's nice, you have access holes. And this one is PLA, this one's ABS. There's no color difference. I'm very happy with that. Because I planned to install screen earlier. Okay, so let's do the side first. They do the back here as well, I think. No, they also screen, we did that. Oh yeah, now I already added this one here before. Okay, if they do the back. This is a full workout, I tell you. It's also like not really helpful. This is like quite a high table. This is like 95 centimeters. So it's not really not really convenient to lift like heavy stuff. Okay, so here I think we need four, yeah, exactly four in total. And yeah, they're far enough spaced out that the orientation doesn't really matter. I'm just paying attention for the last one here. And this is the one with the keystones. Let's quickly align that. Okay. Yeah, well, the skirts add so much to the like visual of the machine. Like it looks so much like more refined with the skirts. And this is the last part. Here's a bit more place, almost like we'll just adjust the parts a bit left and right. Let's get that first aligned. So let me just slide these a little bit together. There's like a bit of gap here on the side, doesn't really matter. More important, it's like no gap in the middle. Yeah, they're like a couple millimeters short, not sure why. Now these are like the separate things are not centered, but like it's the backside, what gives. I'm more happy that the front side is like perfectly aligned. Okay, that's that. We have the white part here already on. We have this. I kind of like interpolated adding the centerpiece. Sides. So now here's basically two sides. Obviously, one side has a fan, one side does not. I'm not quite sure it would make sense to add 4 fans later. Our layout is a bit different. So they add the fans more or less from the back, so facing the side. I think for us, the main thing that needs cooling on the board are these stepper drivers. Long run, I most likely will add a dedicated fan on the bottom panel, forcing air on the machine down here. And then these, most likely, I'll turn around to pull air out. For now, the solid state relay needs cooling. The power supply needs a bit of cooling. And these need quite a bit of cooling. So I think if we push air from this side, like there's quite a lot of flow going over all the parts here onto these, so it should be fine. So I'll put my fans on this side, which means they now assemble the side without fans, so we do this one first. Okay, so I don't think there's order to these parts. I mean, left, right, yes, but there's not really much to it. And then the center part is also here. There's quite a bit of space. Don't like that. Oh, there's the M5. It snug its way in here. So quite straightforward. 1, 2, 3. Oh. Let's start with this one. I'm not tightening that yet because you most likely have to wiggle left, right a bit. Wait, this one doesn't really want to slide. That's like one of the only parts in this kit where I have a little bit of problem with are the T-nuts. They don't seem like super high quality. Oh yeah, and if I could read, it says M3, M3, M5. So let's use the spare M5 I just found in a random spot. Okay. And then most likely we need M5, but also we skipped the assembly of this one. Let's quickly do that. So we use one of the fan vents and one of these back clips here. Let's just like sandwich. And that is held in place then by one M38 in each corner. And there's the orientation to these parts because one corner doesn't have like an indent for the black part to lock into. Actually, for this side without the fans, I also considered printing a mod that just is like a normal side grill, like these, and doesn't have these like fake fans. Okay. Yeah, it's a bit also a bit play left and right. But here's not quite as important, I think. Um then say I M5 510. Let me just quickly dump everything here. I lost quite a lot of M3 by 8 when I put the open back in here. M5 by 10. Here we go. Actually looks quite center already. And if I now screw it in the right way, we're getting places. Yeah? No. Did I do it wrong? Yes, I did it wrong. Which also means I put all the fans in the wrong spot. Hey, let's try this one again. And you know what? Before we now put the fans in, let's actually quickly like the side panel here in with the fans. Let's quickly check how long the fan wires are because I never checked that. Because I have a slight suspicion, looking at these fan wires, I don't think they're super long, which would mean maybe that if we put them on the side of the power supply, they might be too short. So before we do something and then do it again. But now the Voron logo is sideways. Uh, this one is upright. I have a suspicion that there's a left and a right one. And I'm not sure if I printed enough left and rights. In which case we might have to live with like a sideways facing Voron logo. So this one goes in like this. So this is for this side. This one goes in like this. So this is also for this side. This one goes in like this. So this is for this side. No, it's not. Oh, this one I had the wrong. This one goes in like this. So this is the right side. Yeah, it's quite complicated. Turn the other way, yeah. Sorry, Mr. Lisa, I just saw it. No, this is still not correct. And it's quite a puzzle here. Let me quickly check just the parts if I actually, because I think I just duplicated them. These two are the same. These three are the same, so at the very least we are... This one is, so I have one for one side and three for the other side. So, well, I will replace it later. And let's not make this mistake again. That's the wrong one again. Oh my god, this is really driving me nuts. Okay, this one goes here. It's like they're really like ever so slightly different. Yeah, now this is sideways, which is, we have to deal with that now. Because we have not enough correct ones. So for the other side, there should be one correct one, which I think is this one. Yeah. Yeah, this is the only fan grill for this side I have. So this one I'll just reprint and replace. I mean, it's not a big deal. I did not pay attention while slicing these. Could be your test print at the end of the stream. Yeah, could. But it's also one of these things, like if you don't tell anyone, nobody will notice, most likely. So this one goes here, and this one goes here, and this one goes here. So these two are correct. So it's just like this one is sideways. Okay, let's quickly check the fan wires, because I really have my doubts that this is a very long wire, and it is indeed not. So the problem is, if we put this here, I mean, technically it reaches, but this is not acceptable for me. So I think we will put the fans on this side for now, because then we only have to do the short wire run here. And then, I mean, I don't think actually it matters too much which side the fan goes on. But then let's shuffle the manual a bit. Let's assemble this part straight from hell right away. Let's put the wire out on the top here. Okay, that worked well with the fan. I was a bit concerned, but not sure why I was concerned. It's a heatset insert. Sorry for being like on the side of the stream here. Technically, I can just do this, which could make it a little easier or better to view. And then this one we will put here so that they're like exiting more or less together. Yeah, it works. Does it? No, it doesn't. This also doesn't work. Okay, then we do them in the exact same orientation. There was nothing to grab. Okay, then you go here. Check. Don't want the fans to rattle. Okay, so then this one goes in here. I feel like I had a M5 by 10 already here for this. Not quite sure where I put this. Just grab another one. We'll sort the cables in a. Oh, it's straight here. My Allen key held onto that for me. Yeah, I'd rather have these parts aligned on the outside than have a small gap here. Let's do that. This is already, I think it's a little bit like a wiggly setup with one screw in the center, but I mean, it's fine. Okay, then let's do like a 180 turn. Okay. And we do the entire thing just one more time. I see like another. Oh, there was another M5 in here. I saw it. Here you are. Yeah, this is M5. So M3, M5, M3. Bigger screwdriver for this one. Allen key for that. And then we can already adjust them all the way to the side because we know that's where we want them. Now the last screw. Feels like going in here. I would have preferred like a second screw. Like for these on the side, it's fine, but for center one, I would have preferred the second screw. Okay. That's all the skirts, I think. We do need to add the wires here. So they wire both of the fans in like one fan control pattern. But we don't do that. We don't do that. So for us, basically, what we do is we just run both of them just straight here in this cable channel. The only thing I don't like here is like we have the CAN bus. Let me try to keep the CAN bus cable a bit on this side here. But also because the fans potentially also use PWM. And then if you run them alongside the CAN bus cables, can be a little bit problematic. So just let's try to prevent it. So I'll just plug them in here in these fan spots. We need to set some jumpers here to give those fans power. At the moment, they are not connected to any power rail. So this mainboard basically has 24, 5, and 12-volt power rails. We need to pick one for our fans. Here we have a whole bag with jumpers. I think we need to quickly check the manual, which one is. I mean, worst case, we are wrong, because these are 24-volt fans. They're the highest power, so it doesn't really matter. Now you're scared by CAN cable. Yeah, I am scared of CAN cables. CAN cables are like my nightmare. No, it's like I'm not sure what the problem is, and I just don't want to make it worse. Here we are. So here, this is user manual. Let's quickly check. This is not the... Wait, I had like one downloaded, I think. Not sure if it was in this machine. No, it was on the other machine. Let's see if they say here. Oh yeah, so here there's a red one and it says V fan. So V in is 24 for us. So it's the one facing me. And just as a double check quick, yeah, these are 24-volt fans. Not that we know, like put 24-volt on there and they're 12-volt fans or something. So let's just check one more time. I'll get we also didn't set the Nevermore, so I'll get 3 jumpers and then we set 3 jumpers. So it's the bottommost. Yep, so these 3 fans. Just because I have them out now and I know we will have one more fan later on, I already set one for the last remaining fan header here. There, SDF, FB, got a question on your motherboard. What Octopus board is it? Is it just recently bought an Octopus Pro 1.1 H723? This is not an Octopus, this is a M8P. It's a completely different board. It's this one here, Manta M8P 2.0. It's a different board. Don't try 5-volt fan at 24 volt, it doesn't work. I think if you use 24 volt, it spins 5 times as fast for a very short amount of time. Not like I ever tried. I would never do something stupid like that. Okay. I think technically it's bottom panel time, which we can install because I have something amazing for the bottom panel planned. Bottom panel, yes. So I'm very excited after the stream. Like, I already got rid of the big paper box. I still have like a couple of these like white inlets here. And after the stream, I can get rid of them. I'm very excited for that. I think the cutout is to the front. Yeah. Well, it doesn't sit in there yet. I think we are still missing a couple of parts for that. So let's get ready with that. So the standard bottom panel uses these hinges that you can open it, basically. I thought it a bit stupid because like if you don't put the printer like on its top basically as it is now, but you know, maybe just to flip it over, then basically the entire thing just flips on your desk, which is a bit weird. So I printed different ones. And you might not be surprised to know that I used magnets. The only problem is I am not 100% sure right now which of these parts it is. So I have to quickly check the printables. Give me 1 second. Because my entire box there is full of panel clips. And I will link all these like mods I do like in the Discord. Oh no. Did I accidentally? No, these are the ones for the side we used. Yeah, I think this is like a part I recognize. Yes. Okay, so this part, these two parts. So there should be 6 of these. Next time I use little paper or like plastic bags again. Because especially with these clips, like if you dump everything in one bag or like bin, it's getting chaotic. So we're still looking for one of the big ones and two of the small ones. Okay, 5, 5. Which makes me wonder if I screwed up and I only printed 5 of each. No, there's 6. Man, I hate myself for throwing everything in one. Here we go. Okay, so I missed some chat messages. I see a mistake, they look the same. I think they're very similar, but they're different boards. Burn the fan and MOSFET on my EBB36 because stupid me ordered the 5-volt fan. Oh, it also took out the MOSFET? Oh, that sucks. Yeah, I also burned my fair share of MOSFETs in my life. It happens very easy. So that's not super ideal. Okay, so I mean, we see here in the picture how this goes together. It's not rocket science. So basically, we have these longer parts. We VHB tape them to the bottom panel later on. They have 2 magnets. Pretty much it. So we need to do our most favorite thing and press some magnets. Oh god, they're way too far. Into some holes. And I just hope that these are also relatively tight, and we don't need glue. I think they're too tight, which is a different problem. Okay, I can guarantee you we don't need glue. Potentially we should have, or I should have printed that on the V0 because they are tight. I'm quite sure if, like, I know that some M3 6x3 magnets are a little bit bigger than others, and I feel like these are a bit on the big side. Because also with the other part, where you should have used glue, they were so tight that we definitely did not need to use glue. And I must admit, they came fresh off the press today. So I didn't have real chance to check. I mean, this works. They are staying in there for good. Will be just a bit more work to get them in. Now, I'm a huge fan of this, like, quick release clamp and some hard object trick. Like, this works really well. It'll be really snapping. Has it exploded yet? Nothing exploded yet. I mean, there's always there can always be something that explodes in the future, but I'm printed fine for 60 hours so far. And I hope it's prints for another 60 at least. Man, they're like, these are... Oh, they don't break my... Well, seems like this is the end of my quick release clamp here. Yeah, that's... What did I say? You get what you pay for? Okay, I'll check that quickly later. Let me get a second one. 1 second. Okay, let's try again. Printed part 1, quick release clamp 0. Yeah, I think this is as far as this magnet goes in. Let's see. I didn't expect this to be such a pain. I mean, this is not really in, definitely not, but seemingly this is as far as it wants to be in. Just use rock and roll mod for easy access to the electronics and extreme magnets insertion tool broken. Yes. There's also these drawer mods, and I don't know the rock and roll mod, but there's also the drawer mods. But I read that like on the 300 you don't really have the space you really need. On the 350 you have enough space. And like these electronic drawers, they look like really sexy. Which is kind of the second time I feel like I want a 350. I try to not to press too hard now. Yeah, they're kind of bulging out. But it shows you how tough like 3D printed parts can be. I wonder if the tolerances on my print are off, or if it's just like the magnets being a tad too big. This is hard work. Should have done it maybe before the stream, but here we are. Yeah, this was nice. Like this, I can live with this. Halfway done. Wow. I had a journey. Just come back from Printed Amsterdam. I can really recommend it to join next year. That was cool. I super forgot about that. What was your highlight? Oh, let's also pay attention that we do it the wrong way, because now we need to have the opposite. So this way. Quick sanity check. Looks good. It's trickier with the smaller part. Let me use this one as a source for copy. I wonder if I should try to fix this one. I fear there is like a spring inside. I need to check how they work. Because if I open it and a spring comes flying out, it could be quite dangerous. Depending how strong the spring is. But this set of like quick release clamps, they also were not super expensive. So I use them quite a lot now. If I lose now 1 out of 4, I can live with that. Oh, let me see if I can spit more in. Almost there. Magnets are fun. I love magnets. Ah. Oh no, the part cracked. Guess we have to live with one less now. Let me quickly put this aside. I did not print any spares of these. What a waste of magnets. Well, I think it's the best use of magnets. Or do you mean this? I mean, these are recoverable. That was it? Oh no, I put one wrong way. Ah, okay, now it's two less. Getting iffy. How did that happen that I put the wrong way? Okay, I think I'll just leave these two out. And let's take care of them later. I just reprint, like I get the magnets out, that's not a big deal. But I think it will be like a destructive process for the parts. No, this one also cracked, but it still holds. Okay, so we have four, should be enough. These are a little bit of goners. Okay, I'll recycle them and uh, this one is like really weird. I don't feel like I pressed this hard. That this should have happened. I feel like the camera is always sagging a bit over time. Yep. Okay, so then the tiny parts here, I mean it's relatively simple, they just go here. So bag of M's 3x8 is back here. It's quite straightforward. What size is your? This is the 300. This is the 300. The 350 seemingly is like a lot more constrained when it comes to like speed. 250 is too small for me. Like I want to have a bigger machine, so 300 it is. And I already used the whole build volume, or at least like on the bed. Like I already had one print that filled the whole bed. Yeah, the two on the side, I will add tomorrow. I will reprint the parts, recover the magnets, put them back in. I think this should already be enough to hold. So we know this goes in like this. But yeah, it like, I mean, later on it will be the other way around, so it will sit on the magnet parts. But nevertheless, it will be a bit complicated to put the VHP tape on, I think. Right. Oh yeah, it does sit. It should sit. No, it doesn't really sit. So basically the problem will be like, I mean, for those two, we can kind of pull it up to like attach the VHP tape because you kind of need to like have them on the right spot. We still have this VHP tape here from the kit, but that started to be a bit problematic because like the sides start to stick to each other. Let's quickly put these on VHP tape. And then I think I need to quickly get my cutting mat out. I'm also just doing the 4 now. Yeah, like the VHP tape is fine, but like the roll completely is wasted because of the basically here the sides just stick to each other like between the layers. It kind of ruins the entire tape. Let's see, where can I grab this? Just move that over. Get this out. And then we have 1, 2, 3, 4. And you know, actually, if I would have been smart, mhm, if I would have been smart, I would have used this mat to put the printer on. I mean, better late than never. I'll just put it here. Now I can slide it. I didn't want to slide it before on the table because like there are like screws on the top, like bottom now. And I don't want to scratch my table with that. Okay, let's start just with these two. So just, and just to be clear, like these are not the stock panel, bottom panel clips, but like you can just install the stock ones, of course. Nothing stopping you from there. Oh, I also missed the chat again. I'm so bad with this chat. I'm so sorry. Weren't the tickets like 120 euros? Was worth it? Yeah, the tickets were quite expensive. I also checked the tickets. I was considering either a 300 Trident, but came across the Algo Centauri Carbon, and it's basically just barely fits my desired prints. Which size is the Carbon? But yeah, obviously, like the Carbon is a much less capable machine than the Trident. I mean, you had it before, like you kind of get what you pay for. And this is quite tricky. Yeah, so I think these two are good. Uh, or 2.4, yeah. I would like to see more bigger printers. I have some old Giant CR10s. I'd like to convert to Core XY. I'm pretty sure any for the Ender 3, there are quite a bit of like these like Core XY conversion. I don't remember the name right now. But the CR10 is just like a scaled up Ender, and I'm pretty sure either somebody did that already, or you can adapt the Ender mods yourself. That should be possible. Um, And Creality, I don't remember the name of that machine. Very recently launched. I think it was even 350 by 350, like a Core XY machine that was relatively cheap, like 400 euro-ish. But I don't remember the name. It's a bit tricky because you can't really like grab under the panel to like pull it up. Maybe if I do this. And I didn't pull the protective film off yet. And these magnets are pretty strong. I mentioned that before. So 2 are missing each side, which I'm actually not sure, again, like how much they would add. Most likely it's just good for like overall stability, so I will definitely add them. But this is our magnetic bottom panel. Works great. The only thing, you remember how I said like I didn't peel the film? So there's still a protective film now on here. I would say we just keep it on, because otherwise we have to re-glue the magnets. And it seems to be like quite tricky to get off film, so I peel from the inside here. Nice and reflective. So the inside gets the nice one, and the outside gets the protective film. Here we go. And then technically, I think this should also work the other way around. Not quite. Okay. Yeah, it's always like if they are not 1000% aligned, the magnets, like it doesn't work. Same I had on the outside, because this way, right, it snaps like in place immediately. Cool. But yeah, I'll add these on the sides as well. It's already like not gonna come off, but more is better. Yes, the S5 and CR10 Max. Yeah, exactly. I think S5 was the one I saw. 500 and 450 should have enough aluminum extrusions to make a 50-50-70 core XY, I believe. I do have a standard CAD for CR10 S5 Max. Was the 5mm to Trident conversion that I'm going to do for my makerspace at some point. Oh yeah, true. Like you have one of these Ravenkeeper. 1000%. And if somebody does stuff like that, it's you. Imagine a Voron 5. Yeah. Definitely not a hard conversion from CR10 Max. Yeah, it's very similar to the Ender. So I think that should be definitely doable. Okay, so we have these clips installed with a bit less magnets, but we have strong magnets, so should be fine. Then the bottom panel is installed. Again, like you can just go for the standard bottom panel clips, of course. Then these, let's quickly install them. And then I think the last thing to do is to do the words. The fan to get air out. Okay, let me see, how can I flip that? Because it's a heavy machine by now. Ugh. I think let's go like this. Yep. Whew. Heavy machine. So we have M3 by 8. Oh, button head. These are different ones. Uh, 3 by 6 I have. Oh, M3 by 6, yeah. And the M3 hammerhead nuts. Okay. 4 of these bad boys. I have 5. We have the 500mm bad one. Oh god. Got greenlight to convert it. Just need time. Oh man, 500. That's amazing. That's a huge, huge printer. Like what do you even print with like 500 millimeter? But I guess like you need like a 1 millimeter nozzle or something, right? Like a huge nozzle, because otherwise you print like months for like one piece. You really make use of the entire bed. Uh, Around 60 bucks now, yeah. Takes forever to heat the bed. Oh god, I can imagine. I can imagine that this takes a while. And you really have to heat it like for a while, right? Like it also needs to like evenly heat up. DC bed. I hope that the 500 millimeter bed is not DC. And you would need like a massive power supply for that. Okay, then let me figure out which way do they go in? They face this way, but I have to. Oh, you don't see too much now, I guess. So there are obviously two different orientations here. So, oh, I actually had the right one. So it goes in. Like this. No, oh, I'm looking at it the wrong way. This is not the right one. Um, this one is. So they face to the back. But how do you get them in there? Yeah, they fit. Oh no, they don't fit under my extrusions, I think. How can I check that? Oh, they do fit under the extrusions. How do they insert that? So they pinch the belt and then they rotate it in. But it doesn't really go in for me this way. Let me try quickly without a screw. Pretty sure the one we have is 24 volt. Oh wow. Don't put the T-nut in. Yeah, but if I don't put the T-nut in, I'm never gonna get the T-nut in there, right? Also, like without it, it's very tough to get this in. I mean, now I have it in. Let me actually show you what pain I am in. So now it's in here, but now I don't have the screw in, obviously, with the nut. I'm not sure if I can maneuver that in there. I don't think I get this in here. Oh well, now it's gone. But then why don't we not use a hammerhead nut? Oh god. I'm not sure if this is supposed to be this side. Okay, I will change of plans. So we just put them in here. And we use one of these. And I keep regretting that I didn't put um, the gantry footer up. Now I can just... Hey. Let's see which one. I think with the screwdriver, because the gantry is so low, I will have a bit of trouble, but it's... Yeah, this also doesn't grip. Man, this is painful. I expected these four to fly on like in no time. And now we are here. Struggling to get the most basic part on. I'm not sure if this is aligned. Very hard to see. I think it is. Nothing goes in there. I mean, the 6 is just too short to reach that. I'm reaching slowly the end of my patience with this. Because I don't see anything. Yeah, the thing isn't in. I mean, I also don't get this out anymore. What the fuck? I don't think these need screws, to be honest. I don't know why this is so tight. Like, this is impossible to move. I mean, there's nothing to gain from the screw. Like, it's not going anywhere. Let's just accept defeat. Let me see if the others are also like this. I mean, this is only a cover. Like, it doesn't go anywhere. This is good enough for me. This one is way easier. Maybe the linear rail is like an inch further down there. I missed the entire conversation there. Uh, uh, yeah, most of the parts should be compatible with the Ender 3. Like, there's not much of a conversion. And all-wheel drive, definitely. Definitely all-wheel drive. Okay, let's try this again here. We pinch them. We rotate. And it's already pain. Like, these parts are like straight from hell. Like, why do you know, it's just the cover. Like, why do you need to over-engineer this like this? It's just the cover. Why does this need to be so tight? It should take like 5 seconds to put on. I put the stupid rails like 3mm from the top. The problem is, like, with the nut, you have to pull it up here, you have to push it down here, and you have to pull it up here, and then somehow you're supposed to move this all in. This is a stupid design. This is not nice. I don't enjoy this cover here. But we have pretty skirts. Okay. Let's see. So we pull this one up. We pull this one up. And it kind of goes in, but it's like, yeah. Yep, that's very fast. No, please tell me we have a... No, no, we don't have a T-nut there. Oh, God. So to get it out, you have to pull up here on the back. Yeah, I removed the T-nut. Pinch, rotate. I'm not quite sure if it's only me, but I think like the main problem is that my rails are like, I don't know, like 0.5 mm lower than they should be most likely. And then the stupid thingies don't turn. Not it. Okay. And then maybe let's see if with all the knowledge we gained now, we can reattempt the one on the back. Okay, so no, this is just too thick. I'm really not sure if I just put the rails like a little bit too low. The thing is, like, Steve, there's really not like a lot. Like if I take it like this, it goes under. So I don't know. It's not nice. You know, if you know that you have to put this below, like maybe just give like a millimeter wiggle room in the beginning in the manual. I'm not gonna change the linear rails now. The problem is that this like bends up on the back. Yeah, if I don't bend it up on the other side, it goes in. But like, because I have to bend it up, like it doesn't go under the rail. But if I don't bend it up, I don't have like patina in here. And let me attempt to. And the M6 is just like the M3X10, like 6 is just too short to reach it. So I can't really get it like this. This is just shit design, I'm really sorry to say. Like, this is unnecessarily tight. There's no reason to make it this tight. Because like now I can't fix it, and now like this one is just loose. This is really frustrating. Like to get it out, you know, like it really hurts to like bend this piece because it's like really stiff. It has like 3mm ABS. This is really shit. Like this is the worst part of the entire assembly process. By far. And yes, if I would have the rails like let's say like a millimeter too higher, would go in significantly easier. But I don't have that because I have 3mm exactly. That's what we had. I used the calipers to measure this. Nick, this is impossible. See if I can now measure the rails, but we use the caliper with a 3mm offset to set them. Okay, I give up on this. I am getting really annoyed. Most I can tell. It's just like I can't bend them. Like, just to be clear, for sure. Okay, my calipers are on the desk, but I guarantee you, I'll send it later in Discord that this is 3 millimeters. I'm not quite sure if the part is too thick or something, but like, yeah, fuck this. Okay, I reprint this with 2 millimeters. It's like not worth my time. This is really annoying. Like, it's just like unnecessary to make it so tight. You can have like a millimeter space there. It doesn't hurt anyone. Yeah. Let me get my calipers. I want to measure that. 1 second. So my rails are 3.22 millimeters from the extrusion, which is exactly what it said in the manual, right? Like it said 3 millimeters. And that's what I did. 3 millimeters. And this part is 2.84. So it fits under. It's not a problem. It's just like it doesn't fit if I have to bend up the part like crazy here, like a couple millimeters over to maneuver this stupid T-nut in there. And I can't add the T-nut later. It's also why in the manual it says like you have to add it here. This just does not work at all. And yes, if I move the rail up like a millimeter or two, most likely it will work. But it's not what the manual said. Okay, well, that's I'll reprint them with 2 millimeters thick, so like a little bit less, and then it will work. I'm not gonna loosen the rails now and like move it up. That's not worth that. So it's like easier to reprint those. Okay. Okay. Let's ignore this covers. Let's just put all the panels on, and then I think we are close to completing this build. Minus this this cover. Okay, that's the back panel. And this should be side panel. Yes. So that's why I mentioned like it only goes on properly in one spot, which is a bit annoying. I need to mark them. Like this is completely off, so it's most like the other side. Something I need to find a solution for. Potential solution is to, oops, this one is a bit loose, to make sure all the corners are super properly aligned. Because I kind of like threw them on there and then just use the panel, like the position to like adjust the magnets, but most likely you just have to be more precise, or you can just like mark them in some way that you see like which one is which. Okay, exactly. So here's like ever so good. Okay. So these are all the panels and like all the skirts and everything. The only thing missing is the screen and the exhaust. And I think the exhaust is what we're gonna work on now. Let's see. But maybe, like, what's left to do now? So we need to do the exhaust. We need to do the fan, and we need to run the fan wire somewhere on the deck. Then we need to have this cover here. The Bolton tube needs to be run. I'm actually going to skip the standard spool holder because I have something else. So this one we will skip. And then that's that. And then basically there's the screen. So I didn't want to stream like forever today. And we are now at 3 hours, which I think is quite a good cutoff mark. So I'm thinking whether we do one more stream next time where we do the screen, the exhaust, and which is not in the manual, but like we have this light bar that I want to mount most likely here. Need to see if here or here. And that also needs a wire to run. That will take a second because I kind of want to run it nice. um, so I'm thinking whether we just do like one more stream next week to finish the machine completely off and also do the panel clip here. Uh, try to screw the hammer nut. Well, now the part is broken, so. But yeah, they could have helped to put it more in. That's a good one, Mr. DDSI. But yeah, I think let's do like one more stream next week to do the screen. We also need to do the Ethernet and the HDMI cable. So I think, yeah, let's do one more stream next week, part 11. And I will do some stress testing with the cable setup because we also changed the canvas cable here. So I really hope that this solves the issue. I mean, there's really not like any tension on the cable now. Like also in the extreme position, there's no tension here. We now have a PG7 here. We have a PG7 here, and there's no movement on this cable whatsoever. So I will run some tests, and hopefully everything works reliably. Um, yeah, I think that's quite a bit of work done with the skirts and the bottom panel and everything. Small setbacks. I have to somehow get these magnets out of here. I think I will just use some heat to melt the plastic and then they should come out quite easy. And then, yeah, it's pretty much a 2.4. I'm also considering whether we add these center clips here for the panels. I'm still kind of on the fence of that. Like technically, I don't see a reason right now to add them. Like it works fine without. Um, so potentially we just leave them off. But yeah, let's see. I've done Nevermore and Skirts fan. What do you mean? Like you on your build you did the Nevermore and Skirts fan? Oh, we didn't use the fans yet. Let's configure the fans. Let's do that. We can't leave halfway up here. Let's configure the fans. And we also didn't configure the Nevermore yet. So let's do some software. But then let's do the rest of the hardware the next time. Let me turn it on. Is it plugged in? And I'll switch it off. Nope. Oh, yeah, it's on. Check. I see a red LV. Then let me just park this here a little bit to the side because I never use those fans. I'm really curious to hear the fans. I hope they are not too loud. Let me quickly resume my music. Let's see. So That is clear. Not too loud. Let's hope not. So let's configure this in our M8P file. We already are here in a Menta configuration repository. I think there was a config here. Yes, exactly. Fan. So we use basically all the fans now, right? We use fan, no, not all the fans, 0, 1, 2. 0 was the Nevermore, 1 was the one electronics fan, and 2 the other. So let's quickly check that out. So I'll just, oh, they're already here. We just have to uncomment them. They're just completely mixed up. Okay. So this is fan 0. This one is our Nevermore. So I will just leave it like this because there's nothing we need to configure there. We can just call this Nevermore. And then we have the feature. This is called controller fan 1 and controller fan 2. And these are linked to, let's just link them to the bed. So as soon as the bed comes on, we want to cool stuff. And 45 is, let's just say 35 is a fine temperature for that. So basically how that works is we link these fans to like a heater element, in this case the bed. So as soon as the bed goes over 35 or is being heated, these fans come on. Is there a naming scheme for your printers? Yes, they are all names with C. That's the only thing. So I have Clyde is my V0. I have Charlotte, it's my Switchfire. I have Cooper. Cooper is the poor man's Cork Spy, and I have Claire. Why I do that? I have no clue. Fan Nevermore is not valid. Oh, I can't name them? Let's remove Nevermore. I thought I can name them. I can do multiple pin in the fan? I mean, it doesn't matter because I don't have to control them. They're like automatically controlled, so it shouldn't really matter. But this one is the... Yeah, this one is the part cooling fan. I don't see any other fan now. Okay, let me quickly check the Clipper config. Clipper config reference. Fan. Fan. I see one pin. No, it doesn't seem like I only can do one fan. But also I need to call it fan generic. That's a problem. Because fan is really the hot end, like the part cooling fan. So I need to call that fan generic. That is the problem. Fan generic Nevermore. Now it should pick it up. That's the problem. Okay, so yeah, now we have Nevermore here. Let's give it a shot. Ooh, that's noisy. I mean, it works. Yeah, both are spinning. That's noisy. I think 80 is acceptable. Like so far, this is extremely quiet printer. So I'm a bit a bit conscious to keep it this way. But yeah, Nevermore works. We just have to configure that in Orca. I just need to check. Like on my V0, I have a little bit of a funky system. I basically say in the print start G code, whenever the bad temperature is over like 100, no, like above 90, I think, then use the Nevermore. And actually, we can just, because I copied that here, is exactly this. If bad temp is over 90, filter on. We can just copy that over. Yeah, okay. And then we just need a G-code macro. Filter on. And filter off. And in the print end, we need filter off. Let me quickly check set fan speed G-code command. So we say set fan speed. That's easy. So in the filter on, we just say set fan speed, Nevermore speed. Let me quickly calculate. 255 is max, so we want 204. That's 80%. I prefer silence over anything else. And then here we just say speed 0. So filter on, filter off, we have some macros. Yes, it works. Well, it sounds louder than I thought. Oh, I think that's oh, between 0 and 1. I thought too complicated. So in the macros here, it's not 204, it's like 0.8. Sounds irrelevant if you enclose well enough. Well, the thing is, like, the kit comes with the 0 point, like the 3mm panels, and that's what I have. Like, of course, you can slap on like thicker panels, which will enclose the sound more. That's not what I have. Might be upgraded in future. Also, that thing lives in my living room. That's also, you know, like if you have it in your garage or something, I don't care, but it's in my living room. So if I have like 8-hour print, I have to be around the printer the entire time. So sound is for me relatively important, actually. This is the part I'm going to get lost, and I think I will need some help. Well, I posted my entire config in my Discord. There's a link to like a GitHub page. You can just take the entire config. You have the same kit, so it's completely identical. Yes, we also want to check the controller fans. So technically, as soon as I take the bad to 30, yes, I have 2 controller fans here. Stuff is getting noisy. That's okay, but not perfect. I might swap these fans. So on my Switchfire, I also have the 6020 fan. And there I have like from a water cooling company, like a PC fan. It's like way quieter and pushes quite a lot of air. I mean, these suck in quite a bit of air. Let's also do the trick here and say in the macros. Mm, not macros. In the M8P. Let's say here power 0.8. I think it's the keyword. Let's quickly check in the config. Max power. Controller fan. Let's actually declare them as controller fans. Then I think they are on as soon as the motors. Yeah. And then in controller fan, we have fan speed. Fan speed 0.8. So we take them just a notch down. Yeah, way better. Should be fine. Like it's enough airflow, I think. We're also not pushing the machine yet, like extremely. Like it's still like relatively easy. There's air coming out on the other side, so this is good enough. We just have to swap the horizontal Voron logo. I'm taking care of that later. Okay, that is. I mean, there's not a lot of configuration goes into that, but now I also have Nevermore, which is very nice for ABS printing. To be honest, like the ABS I'm using, the Novofill, it doesn't smell a lot. Like even without, like I didn't use the Nevermore at all. I just configured it now. I didn't have any smell in the apartment at all. So I think it's quite good. Also the Form Futura ABS that I use, also no smell at all when I print up. So yeah. Oh yeah, and the sensor, I removed it. You see it's not in the printer anymore. I mean, luckily you can just unplug it. But yeah, I had it misfire. And in the moment it misfires, like this is not a reliable sensor. Bit of a shame. Would have been nice. I already was like running down, or like running one spool down, for like just like using up the last bits. Then I had to observe it manually. But yeah, if it's unreliable and it like pauses the print randomly, it's not good. Now the Nevermore basically is impossible to hear after the controller fans are on. Let's kick the last fan on. It's not too bad. Like it's a very like low hum situation. The loudest fans are definitely the controller fans. So that is on my short list to swap them out. I mean, it's always a bit of like trade-off, right? Like you want airflow, but you don't want to have it like super loud. So I think the like the best thing to do here is like to have the fans on the side, like run on lower RPM. Then what I mentioned is like I want to add like one fan that directly blows air on the steppers. And then you can swap the ones on the PCU out, just turn them around. And then what it does is basically that you just have like a better airflow. Like you're not pushing from one side, but like you push in like from the bottom and then you pull out. And I think you don't need as much like speed on those fans. Yeah, it's not as silent as it was. So I'm a bit sad, but it looks way sexier with the skirts. It's, it's a nice machine. I like the marble. It's like really good. Like turns out really nice. Uh, this we need to fix. There's obviously one cover missing here. And yeah, big difference. Oh yeah, now I can also show that. Like, so I tweaked the doors a bit, just like up, down, like just like moved it around a bit, and now they close like nice. So I now have no more problem with them. I was really just like loosening the screws, like moving up and down, seeing a bit. I didn't sand off more, but I think the sanding here helped a lot, just to make it a little bit more smooth. So that works pretty well now for me. And there's zero gap here in the middle, which I think is important, but also like makes it a bit tricky to adjust. Did you put the carbon in the Nevermore? I don't think so. No carbon in there. Empty. Oh yeah, I totally forgot that I made a mod for that. Because like we struggled to put this Nevermore together in the beginning, right? So I made this easy removable slide-in thingy there that's easier to print and like easier to open and close. Totally forgot that. And the last thing actually, what we also forgot is the nozzle brush. We also still have to do the nozzle brush. Totally forgot that. So in the box here, what we still have is like, I mean, this is extra. Yeah, this is the old hot end and the old mount that we used for pretty much 2 prints. Speaking of waste. This extension cord for the exhaust filter, this is the board we decided to not use. We have some zip ties here still, replacement fuses. This is the brush for the nozzle brush thingy. So I need to check what we need to printer. These are the caps of the DIN rails we forgot. And like 5 screws. They're just randomly flying in here. But yeah, we are pretty much at the end. So I would say, let's call today. And then next week we do the exhaust filter, the light, the clipper screen. I never installed a clipper screen, so there is a bit of a learning curve. And then potentially the center brackets here for the panels. But yeah, it's getting places now. So yeah, then thank you everyone for tuning in. It was yeah, quite a productive evening, I would say. I'm very curious to see if the cable solves the problem now. But yeah, if you build this, like directly build this better PG7 thing there. I'll put the link in the description, or if I forget that, it's definitely in the Discord. So yeah, enjoy your weekend. See you next week. Bye.